This video is going to introduce you to geometric sequences. To start off with, let's define a geometric sequence. Basically, all it is a sequence where the ratio of consecutive terms is constant. Basically what that's saying is if you divide consecutive terms, you're always going to get the same quotient or that constant. And that constant is called the common ratio. And the letter used is R for that common ratio. So just like the previous video, let's look at a first example of just being able to identify if we're staring at a geometric sequence. So the question is this geometric? And let's see, we'll do part A, where the terms start with 4, 10, 18, 28, 40, and on and on and on it goes. Well, to start off with, this is our first term, a sub 1, this is our second term, a sub 2, and third term, a sub 3, and so on it goes. To tell if this is going to be a geometric sequence, what we want to do is divide consecutive terms. I would do a sub 2 over a sub 1. We're going to divide these first two terms. So that would be 10 over 4. And I believe if you divide 10 by 4, you get 2.5. Or 5 over 2. So we would hope to see if this is going to be geometric every time we divide consecutive terms to get the same quotient, 2.5. So it remains to be seen. Let's see what happens now if we divide the consecutive terms, the third term, a sub 3, by the second term, a sub 2. So the third term is 18. If we divide that by the previous term, 10, that's going to be 1.8. Right there I'm going to stop because these are not the same. 2.5 does not equal 1.8, so this would be not geometric. Or I should say this would not be geometric if I spoke proper English on that. Let's go on to B. For B, let's say I start with 625, then go down to 125. Then go to 25, and then 5, and then 1, and there it ends. Well, here's my first term A1, second term A2, third term A3, fourth term is A4, fifth term is A sub 5, right? So once again, we're going to look at the quotients or the ratios of consecutive terms. Let's do A sub 2 over A1. That's going to be 125 over 625. Now, if you reduce that, that's going to be 1/5 or 0.2 to start. Right now, we can't say whether it's geometric or otherwise because we have to check another couple of terms here. Let's do a sub 3 over a sub 2, the consecutive terms there. If I do that, that's going to be 25 out of 125. That reduces also to 1/5. Which is 0.2. So far we're looking good for geometric. However, we have to make sure that all of the terms are completing that same ratio. Let's do a sub 4 over a sub 3, the fourth term over the third term. That would be 5 over 25, which is 1/5, which is 0.2. We're looking good. The last one to check is probably the most obvious, a sub 5 over a sub 4. That would be 1 over 5, quite literally, and it is 0.2. Notice how the common ratio is 1/5 or 0.2. So this is geometric. So I'd say yes, it is geometric. The R value, by the way, you can write as a fraction, 1/5, or you can write as a decimal, 0.2. Okay? Now, next thing I would like to show you is the rule to create the nth term. So the rule for the geometric series. is as follows. The nth term is going to be the first term, a sub 1, times the common ratio r to the power n minus 1. Okay, so I'm going to quickly maybe pick a couple of examples, show you how that can be used. So in this example, example 2, I want to write the rule. Alright, so for A, let's say the series, or excuse me, rather the sequence is 4, comma 20, comma 100, comma dot dot dot. Keeps on going forever. So, in order to do this, I have to figure out what is my common ratio r. Well, to do that, we're going to divide consecutive terms. If I divide 20 by 4, I get 5. Same thing as if I divide 100 by 20, I still get 5. That common ratio is r. So right now I know my r value is 5. The other thing I need to know is my first term, which is given to me. It's 4. So a sub 1 is just 4. And I got to plug it in. So I'm going to write a sub n, my rule, is going to be the first term, 4, times the common ratio, 5 to the power n, take away 1. And just to show you that this works, if I wanted to find my first term, I would use the formula by going 4 times 5 to the power 1 minus 1. That simplifies to 4 times 5 to the 0. And hopefully you remember anything to the 0 turns into the number 1. And 4 times 1 is 4, which matches my first term. And on it goes. Let's see if you can do this one with me. Let's do one more with you. That's a little bit trickier looking on the surface. Let's do 152 as our first term, then negative 76, then positive 38, then negative 19, and then I think it will just stop there. Okay? So to get my ratio, I'm going to divide consecutive terms. I'm going to do negative 76 over 152, which reduces to negative 1/2. If I kept on going, and it depends. If it tells you it's a geometric sequence, you can stop just by doing that. If you're not sure if it's geometric, you should probably continue. By the way, that's a 76. You should probably continue to divide consecutive terms, like 38 divided by negative 76. That reduces also to negative 1/2. And so on it would be if we did negative 19 divided by the 38. It reduces to negative 1/2. So I know my r value is negative 1/2. I know my first term is 152. So my rule for the nth term would be a sub n is my first term, 152. Then in parentheses, I'm going to put my r value, negative 1/2 to the power, and take away 1. This would be my rule. We can generate many terms of that sequence by using it. I'm going to see